on the final, your options are, right? Your class is scheduled to take it at 1:30 on Friday afternoon. If that time doesn't work for you, or you just don't want to do it on a Friday afternoon or whatever, you're welcome to come to any of my 4 final sessions, right? And they are as follows: Wednesday at 1:30, Thursday at 1:30, Friday at 1:30, or Thursday evening from 5 to 8:30. I'll be giving it to my online class, right? So it's the second half of the week. Wednesday 1:30, Thursday 1:30, Friday 1:30, or Thursday evening 5 to 8:30. Right? All of the ones in the afternoon will be in this room. Right? So 1:30 from Wednesday on in this room, or if you want to do it in the evening on Thursday, you can go to the room next door to this, Morgan 151, and it'll be I'll be in there from 5 to 8:30, but I'm leaving at 8:30. So don't show up at 8:15. All right? Got it?
They're all in here, though. Can you repeat the first session time?
Wednesday, 1:30. So it's Wednesday, Thursday, Friday, all of them at 1:30, or Thursday evening.
Where's the one Thursday night at?
Next door.
They're all in here.
Morgan 151.
The one on Wednesdays in here.
Okay, listen up. They're all in this room except the Thursday evening one, which is next door. Right? And that's in Morgan 151. Right? If you plan to come to one of the other ones than you are scheduled for, you guys are scheduled for Friday at 1:30. If you want to come to one of the other ones, then just shoot me a quick email note and let me know that. All right? It won't be a problem. I just want to keep track of how many people are coming each time, so I make sure I don't run out of chairs. All right? It's never ever happened before that I've had an issue with chairs, but I just want to keep track. Okay? Yep.
Friday 1:30 in here.
Yes. So the final is comprehensive. You might have heard that a couple times. You get how many cheat sheets? One cheat sheet. So you need to consolidate all your previous cheat sheets into one to bring into the final. Right? Now, what is the best way? Research has shown what is the best way to study for a final? Stay up all night the night before, drink 4 pots of coffee, and don't get any sleep. That's the best, right? No. Research has shown. Have you ever had the experience that if you're working on something that's difficult and you give up and you go to sleep, and then you wake up, as soon as you wake up in the morning, you go, oh, I know how to work that problem, right? Your brain continues to organize. Your brain continues to organize information after you go to sleep. So the best thing you can do is study every evening between now and then for about an hour, right? And then go to bed. Let your brain organize it, and then do the same thing Thursday night before this final, right? Then if you don't have a final Friday morning, you can get up and kind of look through things again, be ready for the final. Right? Don't panic about the final. Don't stay up all night and cram. It just doesn't work very well, particularly for mathematics and statistics type subjects. It just doesn't work. If it's a history class and it's all memorization, then maybe you could get by doing that. But if it's logical thinking stuff, your brain doesn't function very well if you don't have enough sleep. So that's my little soapbox for you. Any other questions about the final? Yep.
Will there be a review guide?
Good question. There will not be a separate review guide for the final. Right? The only new material we've had since the last review guide is what we're going to finish up today, the hypothesis tests and confidence intervals for regression. Right? So that'll be the only new material, and you've got a homework assignment over that already posted out on D2L. So that'll be your review sheet, that homework assignment. All right. Now, speaking of that homework assignment, everybody get my email over the weekend? All right. Check your email. Actually, you don't have to check your email since you're hearing this, but post it on D2L. Under Chapter 12 module is, I think it's titled Section 12.3 Homework. It will not be in the Hawk system. I don't like the questions they had there, so I just made my own. I'll show it here in a second. But go out, get that document, read it. There's 2 Excel spreadsheets also in D2L right next to it. One for females, one for males, shoe size and height. And that's what you're going to do. You're going to use Microsoft Excel to analyze and produce the regression equations for those 2 sets of data. Okay? I've also posted out there the PowerPoint slides that I've been going through. I started last, I don't have it on. I started last time and I'll finish today. This is out there, and so I'll show you just real briefly on this today. It has some Excel instructions in it. Teach you how to do it with Excel. You don't have to get all that copied down while you're in here today, and I'm doing it. I'm clicking, you're clicking buttons too fast. It's okay, it's in the spreadsheet, right? And I will help you by email if you do get stumped as you're trying to do it in Excel. This is not an Excel class, but it's good that you learn at least just one thing to do in some software other than your TI-84 calculator. Okay? So let me pull up that homework sheet before I go any further. Can everybody read that okay? So this gives a lot of instruction about where to go get the data that you need and the instructions and all that stuff. And then raise your hand if you do not have access to Microsoft Excel on either your computer or a home computer or a roommate's computer or anything like that. Everybody has access to Microsoft Excel? Microsoft has done a pretty good job of infiltrating the marketplace, haven't they? That's good. So then I don't have to talk about this. If you don't have access to Microsoft Excel, you can always remote desktop into a Washburn server and use it on there. Right? But since it sounds like all of you got it, I won't talk about that. But if you later decide, I need to do that remote desktop thing you were talking about, I'll explain it to you by email. Okay? So then what you're going to do is you're going to pull up, there's 2 spreadsheets that have, they're basically, it's all of your survey data that you sent in, but it's broken out by males and females. Right? Right now it's in 2 separate spreadsheets, but as I was teaching last hour, it occurred to me, well, this would be a lot simpler if I just make 2 sheets in the same spreadsheet, one with females, one with males. So that's what I'm going to do. So I'm going to replace the 2 that are there now with one that has 2 sheets. But anyway, you're going to go get that spreadsheet, right? And then I've got a series of questions that you're going to answer by doing the regression analysis within Excel. Okay, so this is out there on D2L. The PowerPoint that has the instructions is on D2L, and the spreadsheet itself is on D2L. So you'll need all those things. Okay, so let me go back into the PowerPoint slides, and I will pick up where I left off last time. If you remember, we did a little bit of a refresher about linear regression, and then I was going through an example of female height and shoe size, and we're going to finish that up. I pretty well finished it, but now I'm going to go do it in Excel so you can see how it's all done there. Remember this? We went through this last time, but SSE, what does SSE stand for? It's the title of the slide. Sum of squared errors. So it's the residuals are also called errors, right? Prediction errors. So the residuals squared and summed up, that's the sum of squared errors. Now why do we need the sum of squared errors? What is it used for?
Finding the best fit line.
Okay, finding the best fit line. The line of best fit is defined as the one that minimizes that sum of squared errors. Right? Luckily for us, it's all done automatically using a computer, and we don't have to try 1,000 different lines and see which one gives us the smallest sum of squared errors. But that's what the computers do. we can then take this sum of squared error and get an estimate of the variability of the residuals. And that's what this thing was. I must have went past it. Wow, can't find it. There, that's the sign of it. S sub e. Right? If you take the sum of squared errors, you divide by its degrees of freedom. We talked about this last time. Right? This is very similar to what we did at the very beginning of the semester for standard deviation. We took the sum of the squared deviations from the mean, sum of squares. We divided by the degrees of freedom, and then we took the square root of it. That's all we're doing here. We're taking the sum of squared residuals now. Instead of minus x bar, it's minus y hat. Dividing by its degrees of freedom, it's the same thing. So this is an estimate of standard deviation. The book uses the term standard error of the estimate, or standard error of estimate. I don't like that phrase. I've never seen it said that way in any other book. I've seen it called standard error of regression, but don't worry so much about what it's called, just know what it is. S sub e is an estimate of the standard deviation of the residuals. So I blew past the slide right here. This is a graph of the shoe sizes and heights for women with the residuals marked in red. So if I just took those numbers, whatever they are, this one's going to be a negative about 1.5. This one's a positive about 1. A positive 0.25, or whatever they are. I'd put those residuals into a list and told it to do the standard deviation of them. That's that S sub e. It's standard deviation of the residuals. Right? How much variability is there around the line? Now remember, we did this last time, but I had you enter into your calculator and run the analysis, and we got this output. Okay? So let's review a little bit. What are we looking at here? We did this way early in the semester and picked off a few of the numbers that we used, and now we know all of the numbers in here. Right? So first of all, this is women's shoe size used to predict height. So height with a hat over it. What's the regression equation? You can also write this as y hat. I don't care whether you use the actual name of the variable or y, as long as you get them in the right spot. What is the regression equation from looking at that output? Okay, 51.3475. That says A. And then up here it says y is A plus bx. Right? So y is height. So A, 3, 4, 8, if I go to 3 places. Then plus
1.68.
1.68, and it's a bunch of zeros after that, or 1 0, so
X.
times x, and x is shoe size. So again, you could write that with an x, or you can write it with the name of the variable that you're actually dealing with. I like to do it the top way because it helps me remember, what am I doing here? I'm predicting height from shoe size. Okay, so those numbers you knew. What is R? That one we did way back then. What is R? Correlation coefficient. It's 0.9. What does that tell you? It's a strong positive correlation. 0.9 means the points are pretty close to the line. Right? So the residuals are fairly small. What is R squared? What'd you say? Well, yeah, you said the line of something, right? But That's the line. So what is r squared? Nobody remembers? You got about 2 weeks to get this figured out. If you square the correlation coefficient, they give it a new name, the coefficient of determination. But what the heck is that? Remember this phrase? It's the percent of variability. Still not ringing any bells? Percent of variability in height in the y variable that is explained by the x variable, right? In this case, shoe size. So how much variability in women's heights can be explained by knowing their shoe size? Back to the graph. If I ignore the line, my smallest height of a female was this point right here, which is about 57 inches. My tallest female was about 70, what, 3 inches? So that's my variability in women's height. But if I look at the variability around the line, it is much less than that amount of variability. It's about this amount of variability, right? So that r squared is how much that variability went down. It went down 81%, right? It was 0.81. So 81% of the variability in women's heights can be explained by its linear relationship with height. Okay, so now we got some new stuff. There's a t here. What is t?
Test
It's a test statistic, that's right. And what's it testing? What is the null hypothesis? It's kind of written for you. The alternative is written up there. We did this last time, but the two tests are equivalent, right? Either rho is equal to 0 versus a two-tailed test, rho is not equal to 0, or equivalently, beta 1 is equal to 0 versus beta 1 is not equal to 0. And these two are testing the same thing. To say the slope of the line is 0, meaning it's a horizontal line, is the same thing as saying there's no linear association here. As x gets bigger, y is not changing. It's staying flat. Right? So equivalent test. So this is the test statistic for testing that null hypothesis. Now in this case, it's a 7.28. It's a t-test. Is that a big number? 7. Yeah, it's huge. P, what is this? What is the p? P-value. It's the p-value for that test statistic. So it is 9.686 times 10 to the negative 6th power. That's a really small p-value. So what's the conclusion? Reject the null. The null says slope is 0. I'm going to reject that and say, well, the slope is not 0. It's 1.68 in this sample, but in the population, that's strong enough evidence to say, well, it isn't going to be 0 in the whole population. Now, let me back up a slide or two. I did this, I mentioned this last time also, but this is the raw data, shoe size and height for each of these 14 women. If I take the predicted value by using the equation, I just plug in the shoe size into that equation, and I get 59.75 if I plug a 5 in. If I plug a 5.5, I get 60.59, and so on. And I just did it all within Excel. Then I compute the residual. How do I compute the residual? What is a residual?
The distance between the point and the line.
The distance between the actual point and the line. So it's y minus y hat, right? So residual is y minus y hat. So I've done that each time. Here's y, 57. Here's y hat, 59.75. 57 minus 59.75 is negative 2.75. Right? See how it's done? Then you square each of those residuals, and then sum them up, and you have the sum of squared errors, SSE. I know what you're thinking. God, I hope this is done automatically. It is in Excel, but not in our calculator. In Excel, it'll compute the SSE for us automatically. It does not compute it in your calculator. You can do all this with lists, but when I did it, I came up with a sum of squared residuals, SSE, of 49.33 approximately. If you divide by the degrees of freedom, take the square root of it, you get about 2.027. Right? Now interpret that number for me. 2.0, it's about 2.03. 2.03 what? Remember, I keep saying I'm really proud of you if you can compute these numbers. But if you can't tell me what they mean, then you're not getting full credit.
That's the average, like, standard deviation. Or the
Of?
error, like the residuals.
From the regression.
Good. That's right. Written under here if you just wanted to read it. But it's the typical amount of deviation from the line. Since what we're doing is predicting height, it's in the same units as height, which is in inches. So this is about 2.03 inches. So what it's saying is all of the points, not all the points, most of the points fall within about 2 inches on either side of that line. Right? The empirical rule applies to residuals. So we can say about 68% of females will be within 2 inches of the predicted value if I just know her shoe size. Right? Emily, what's your shoe size?
7.
7. What does the line predict her height would be? Well, I can go back. We can do it on our calculators, or I can go back to the one where I've predicted for all the shoe sizes, see if I have a 7. Yeah, I got a 7. It says for somebody who is size 7 shoe, predicted value is 63.111, which is what you would get if you plug a 7 in right there. How tall are you?
5'4".
5'4", which is 64. So it predicted she would be 63.1. So what is her residual? 0.9, right? Positive 0.9. Well, we just got done saying that 68% of females should be within 1 standard error, or within 2.03 inches, right? And she was. She was within 1 inch of the line. Man, that's a good line, isn't it? It's doing pretty good. Well, the R-square statistic is a measure of how good is the line doing. It's explaining 81% of the variability. That's pretty good. So it's doing pretty good. Notice in the output from our calculator, that number S, 2.027. So it doesn't give you SSE, but it gives you S directly. So on the final, if I give you a table of data and I say fit this line, give me the line of best fit, and what is the standard deviation of the residuals? You read it right off your calculator. S is 2.07. Right. Any questions on that? All right, let's go to Excel. So I'm going to analyze the same set of data, but use Microsoft Excel. I'm going to zip through a few slides here just so you see what's in this file. This file is posted for you to get, but then I'm going to just go to Excel and we're going to do this. Right? So within Excel, this is just a screenshot. The first thing you're going to do is you're going to enter the data in columns. So you have an X column and a Y column. You can't enter them as rows like that previous slide because I tried it and it doesn't work. So they have to be in columns. Right? So you're going to click on the Data tab up at the top. And then when you click it, over here to the right should be something that says Data Analysis. Now, most of you will not see that the first time. And if you don't, you're going to have to load it in. So the next few slides in this document teach you how to load the Analysis Toolpak add-in, which has regression in it. So that's what's in this file, right? So I won't go through it right now, but, well, how many, I told you to bring your laptops, and so I see quite a few of you did. How many of you do not have that Data Analysis tab? Are you not finding it? Okay, well, I'll go through this pretty quick, because almost every single one of you is going to have to do this. Click on the File button up here at the top, and a menu will drop down that'll look like this. Everybody see that? Now this is a newer version of Excel. If you got an older one, it won't look exactly like this, but all the same options are there. And down at the very bottom it says Options. Click on Options. And then this will pop up. Right? It's in a different screen, so I'm just combining two screens here. But you'll see over here on the left the words Add-ins. Click on Add-ins. And then this pops up. So when you click on Add-ins, you get a whole list of things that you can add into Excel. They're on the hard drive, but they're not going to, Excel doesn't load them automatically because most people never use them and they don't want to eat up the memory. Right? But you're going to need it, so go ahead and load it. Once you load it once, it'll always be there. Right? So the very top one says Analysis Toolpak. So highlight Analysis Toolpak. Go down here to the very bottom. It says Manage Excel Add-ins. Go. And just say Go. So click on Go, and then click OK. Then it should just go away, and you'll be back into your Excel screen.
It gives you like two options. It has like Analysis Toolpak and like Analysis Toolpak like
VBA. Yeah, do the one without the VBA. VBA is Visual Basic something. It's a programming language that sits on top of Excel. You don't need that. Okay? So once you do that, then you can go into Excel and the Data Analysis tab will be there. So I'm going to clear out, I did this last hour, but I'm going to clear it all out and redo it for you guys. So when you first start, you're going to have, well actually let me show you what you're going to have. You're going to have the full data set, so it'll be like this. Right? So I haven't done it yet, but down here at the bottom is a tab that says Females, and then this one will have Males. To navigate between tabs in Excel, you just click on them. Right? So when you want to do the males part, you click on the males one. You do the females, you click on the female. Got that? So here's the females. It's the same spreadsheet you've been looking at all semester, only it only has females in it. Right? It's got a lot of columns you don't need, so I'm going to show you in a second how to pick the ones you need for the particular analysis. But for us, height is the Y variable, so that's in column E, and shoe size is the X variable, that's in column F. Right? But the example that I'm going through right now with only the 14, those are in A and B, but that's easy. All right, I'm ready to analyze. So what do I click first? Data. Click the Data tab up the top. So when I click on Data, a little pop-down menu comes up, and clear over to the right-hand side, it says Data Analysis. After you've loaded the add-in, that'll be there for you. So click on Data Analysis, and this little pop-up, you can use this, and it keeps following you over there. This little pop-up window comes up, and it's got all the things that are in that Analysis Toolpak you just loaded. Right? Lots of cool stuff in there, so have fun. Play around with it all Christmas break. But what we need right now is regression. So go down to regression, highlight it, click OK. and up pops this little window. I've already done it once, so all mine are already filled in. Yours won't be. But the top box says input Y range. Right? So click in there. You can type it in if you want. I'm going to go ahead and clear all of mine out, just so it looks like what yours is going to look like. But click your mouse into that box, and then you can drag across the cells you want. You don't have to type them in. So just click in it, and then come over here, and I'm going to drag across the height column. And I purposely used the very first cell that has the word height in it, and then I'm going to tell it that I did that by putting a check in the labels box. And that makes the output easier to read because it labels it with whatever those column headers are. Right? So B1 to B15 is my Y variable. For my X range, I'll click in the X range box. Do the same thing, drag across shoe size. And then this confidence level, that's part of what's in this lesson is confidence intervals on the parameter estimates. And that comes from here. But you actually don't have to put a check mark in the box if you want 95%, because that's the default. It's just going to give you those. If you want something else in addition, then you would check it and put 99 or 90 or whatever, and then you'll get both 95 and down. Right? So we don't have to do anything with that one. Then this one, I've already checked it, but it won't be at first. Click that radio button, output range, and that's just to tell it I want to decide where the output goes. So when you click on that, you have to then click in the box over here, because I don't know if you noticed, but when I click on that, for some reason, it jumps the cursor back up to here. If I just go out and start dragging across cells, it changes my Y variable instead of output range. Hacks me off. So click in that box, and then just click in the cell you want to put the data, put the output. You don't have to drag across the whole range where the output's going to go. You just upper left. Right? So it'll start in that column and cascade down from there. Then down here under residuals, I put a check in the box by residuals, and I put a check in the box by line fit plots. You won't need to do either of those, but you can play around with them. If you want to see a plot of the residuals just themselves, you can put a check mark in that. I'll go ahead and check that one also, and then just say OK. And there you go. It gives you the regression output. So now, anytime you use software to do statistical analysis, you have to learn how to read the output that it gives you, because they're all a little bit different. Up at the top, it says multiple R. Notice the number there. Does that number look familiar? That was the correlation coefficient R that we were looking at before. It used a little r in our calculator. This uses a capital R, and it puts the word multiple in front of it. Well, just be warned that the multiple R is the absolute value of the correlation coefficient. Right? They're stripping in. This one was already positive, so it's the same. But if we had had a negative correlation, it would show a positive there. The multiple is to handle multiple x variables at the same time, and then they take the absolute value. So if you notice that your slope is negative, then you got to remember to put a negative on that when you report what the correlation coefficient is. Then r squared, that's our coefficient of determination that we saw before, 81% of variability. Standard error. What is standard error? Look at the number. We saw that number a while ago. What is that?
S sub E.
That's the S sub E in our book, right? The standard deviation or the standard error of the residuals. Right? So the book just calls it, or the Excel just calls it standard error. Right? The book called it standard error of the estimate. Then observations, it tells us we had 14 observations. ANOVA stands for analysis of variance. I don't care if you know that or not. I'm not going to hold you to that definition, but that's under the ANOVA is the part of the output that we get the SSE. So what do you think SS stands for?
Squares.
Sum of squares. Yep, sum of squares. Okay? So residual is another word for error. So the SSE is the sum of squared residuals. There's that 49.328 that we saw earlier. Right? Degrees of freedom are 12. Where do the degrees of freedom come from in regression? N minus 2. So there's 14 observations. 14 minus 2 is 12. Anybody get a guess of what MS stands for? Well, I'll tell you what it stands for. It stands for mean square. This is sum of square, this is mean square. Where does that number come from? Think about what the word mean. The word mean means. Right? You're averaging, you divide by how many. You take the sum of squares, divide by the degrees of freedom, you get the mean square. So if you take 49.3, divide by 12, you get 4.11. Right? Now wait a minute. If I take the SSE and divide by n minus 2, didn't we see that somewhere in the formula earlier? If I take the square root of that, that's SE. Right? So the root mean squared error is SE. Some software actually uses that term. They'll write it out. ROOT space MSE. Root mean squared error. And they're giving you that statistic. Okay, so then down here in the second half of this table, it says intercept and shoe size. And then it has coefficient, and the columns aren't wide enough to see the words, so I'm going to widen them out. But column E has coefficient, column F has standard error, and then T-stat p-value. Do these numbers look familiar? They're called coefficients. Coefficient for intercept, coefficient for shoe size, coefficient for shoe size. Coefficient means the number being multiplied by it, right? So that is the slope. And the intercept, obviously, that's the intercept. So if I give you on the test some Excel output that looks like this, and I say, give the regression equation, you're just going to read it right off of here. There's your A and B out of your calculator, your B0, B1 in the notation of the book. Just intercept and slope, write it out. Standard error, we won't learn how to compute these standard errors, but Excel gives them to us automatically. To form a hypothesis test for whether the slope is 0 or not, you take the parameter estimate, divide by the standard error, and you get a test statistic. Does that 7.28 look familiar? That was the T that our calculator gave us. And the same p-value we saw before. A test for whether the intercept is 0 has a test statistic of 25 and a p-value that's even way smaller. But, you know, usually we're not really interested in whether or not the intercept is 0. You just kind of know that anyway. It either is or it isn't. It's not something you really need to test. But there are situations where you might. So it'll be the shoe size line that we care the most about, right? The X variable. So we get a really significant p-value. So what is our conclusion? Remember, what are we testing there? I hate it when people quote p-values, but then they don't really know what the null hypothesis was that they just rejected. What's the null hypothesis? Slope is 0. So this t-stat and this p-value is testing whether the population slope is 0. The sample slope is 1.68. Clearly that's not 0. But this tells me it's far enough away from 0 that it can't be just explained by random chance. Now, the last thing that's new are the confidence intervals on those parameters, and they're given out here. So the confidence interval for shoe size, that's the confidence interval for slope, is, let's see, 1.1778 if I round to 4 places to 2.1831. Okay? So you see how to read the output? It says lower 95, upper 95. So that's the lower bound of the confidence interval, upper bound of the confidence interval. It repeats itself. I don't know why, because I didn't put a check in that other box, but you can ignore one. Interpret that for me. It's a confidence interval. So how does that sentence always start? We are 95% confident of something. What is it we're confident of? No? Good. She said that the mean shoe size is in there.
The mean residual shoe size.
Man, I heard like 14 different things. They were all different. They all sounded intelligent. Most were wrong. But what Jacob said was right. And it's complicated. I would have accepted the word slope. Right? But what he said, say it again.
The mean change in height per unit shoe size.
The mean change in height per unit change in shoe size. That's the definition of slope, right? The mean change in height per unit change in shoe size is somewhere in this interval. In our sample, it was 1.68, which by definition is the center of this interval. But in the population, this is only 14 women. If I'd have gotten all women, where would the slope be? Well, I don't know, but I'm 95% confident it would be somewhere in this interval. Now, based only on this interval, conduct this hypothesis test. What does that confidence interval tell me about the null hypothesis? The null hypothesis says that the population slope is 0. The interval says that it's not 0 because 0 is excluded. And it's not only excluded, it's way excluded. If I draw a number line and there's 0, 1, it's more like a number hill. A number line, 1, 2. This interval is 1.17, so about right there, and 2.18, so about right there. So 0 is not in the interval, but it's not even close to the interval. That tells me I got a really, really small p-value. Remember, the interval and the p-value have to go together. They both have to make the same conclusion about the population slope. The p-value rejects it, so does the interval. Okay? So we are 95% confident that the true slope, the true rate of change of height per unit change in shoe size is somewhere between 1.17 and 2.18 inches. Now let's look at these plots that we had. Well, actually, let's look down here. If I scroll down, I get, remember I put a check box in the residuals box? This is what you get. It's below the other table. You get a column of observation number, a column of predicted heights, and a column of residuals. Now earlier I showed horizontally the same numbers that I had computed in lists in my calculator. And I went back and looked, yeah, they all match. Right? This is more decimal places of accuracy, but look at those residuals. Remember what we said the standard deviation of the residuals was? What was that number we computed a minute ago? 2.03, right? It was about 2.03. Well, look at the residuals. You got some positives, some negatives. Some are bigger than 2. Most are smaller than 2. On average, they're about 2. So the standard deviation is about 2 inches from the line. Okay? If I take this column and I square each of these, sum them up, I got sum squared error, SSE. The same number that they computed for us in the ANOVA table. Now if I look at the plot, I got a shoe size, oh darn it. I got a shoe size line fit plot. That's an ugly graph. I like pretty graphs. That's an ugly graph. The default graph that Excel gives you when you do regression, they're pretty ugly. But if you know a little bit, I'm not going to teach you, but if you know a little bit about how to use graphics in Excel, you can make these plots, you can use these as starting points and make them a lot prettier pretty easily. But you won't need to do that for this class. But it's the same plot that we were looking at earlier. It was a lot prettier plot, the one that I had with the residuals marked on it. But the square red boxes are the line, right? The predicted values, and they all fall directly on that regression line. The blue diamonds are the actual values. So if I collapse the axes, I can make it look better, but then it's the same plot, just not as pretty as the one you saw before. Then this is called a residual plot. So basically it's those red lines that I had drawn before. That's what each of these are. So they spread around. The 0 kind of represents the regression line. They spread around the regression line. The amount of variability around that line looks like plus and minus 2. Oh, SE. SE was about 2 inches. Right? So most women are falling within about 2 inches of the regression line. All right. So on the test, I will have the same kind of question that you had in the first time we went through linear regression, where it might give you, 8 points or whatever, enter them into your calculator, run a regression equation, then add some of these other questions about SE, about variability around the regression line, that kind of thing. But then I will also probably have a different question where I give you Excel output like this. And I say, basically, interpret. So in that PowerPoint presentation, I didn't do this, the authors did. They give you that same Excel output for a different example, but then they annotate it with these numbers. And then the next slide will say, number 1 is the correlation coefficient. Number 2, and so on. And so you've got all that explained here, how to read the Microsoft Excel output. Okay? And this is what I will expect you to know about this lesson on the final. It won't be a big part of your final, but there will be a question about it. So, now is your chance to ask me questions before I get to ask you questions. Everybody understand how to do regression in Excel? It looks real easy when I'm standing up here doing it and clicking the buttons. Oh yeah, as soon as you start doing it, you're going to have trouble. I guarantee you'll have trouble. But just refer back to the slides. If you still don't understand, just email me. I'm willing to help you get through this Excel thing.
Which one's the X, which one's the Y?
What's that?
Which one's the X axis, which one's the Y?
Height is Y and shoe size is X. Okay? All right. I will let you go. We will see you. I might have already said this, but bring your past 3 exams with you on Wednesday and Friday this week. The rest of this week, we're just reviewing for the final. And we're just going to go through those old exams, so come with the ones you want to ask questions about.